Okay, let's get this show on the road. Hello, everyone. Hope you're well. Welcome to another edition of Math 1108. Hopefully you guys are doing okay. Let us jump into it. Make sure I can see the chat here, just in case. Okay. Okay, so the plan for today is to get through those problems I left you guys with for exponentials and logarithms. And in fact, last time I put you guys into groups, I know you didn't have time to do anything, but hopefully you guys did something over the weekend. So let's go through this. So today we're going to wrap up chapter 2. We'll be doing a lot of computationally heavy stuff. Heavy in the sense that we're not using technology, we're not using calculations. We're going to do this all by hand. We can do this naturally. And admittedly, you probably won't have to do anything as crazy in general for calculations later on in the class. So you guys might, at the end of the day, wonder, well, why do you do that? So there are going to be a couple reasons for that. First of all, just there are certain concepts that I want to hit home here about how you want to think about stuff, especially mathematical stuff. Things about when it comes to rules and regulations and things about that kind of thing, how to actually know you're following them, know when you're complying. Just really want you to build up the kind of pedantic nature you're going to need in business and finance and all that sort of thing. And math is a great place for that because you have to be very pedantic with math. As well as if you can handle this stuff, you can handle any of the math I'll be throwing at you later on. A lot of the things that we will be doing, there will be word problems. So you have to read a situation, translate it to mathematics, and then solve it using the mathematics. So you have to have the math skills at some point, but what better way to prepare than to be over-prepared, right? If you can do things that's harder, then when you do what you're required to do, you'd be awesome at it because it's a step down from what you're capable of. And I think that's a good thing to strive for in general. So that's what we're going to do. Yeah, so you guys can turn your cameras on. That would be great. Make it a little bit more personal. We're about to go through the trenches together, and we're not going to pull any punches because, as I mentioned, I expected you guys to look at this over the weekend, so not really going to go through this very slowly and painstakingly. I might pause a few moments to ask you guys questions, but other than that, we're kind of going to try to rapid fire get through this. I thought it would be fun, though, if we begin by some guessing, like what you guys thought the answer was based on what you guys did. So maybe the people in group 1 can tell me, what you guys think the answers should look like. So like 1A, what are we thinking? Is the answer for 1A? No, too tough. 1B? Oh, I have a guess in the chat. You don't have to be shy to speak up, but guess is a half. Okay. Any guesses for 1B? Three. Someone guessed 3. Okay. Same person. Was Cullen the only one who did it? Guesses for 1C? Maybe someone else? Did anyone in the group help Cullen out, or?
Yeah, this one I was just kind of confused on because like the exponent being both like ln's. I just wasn't sure what to do.
Yeah, but did you have a guess, or did you just
I mean, I like just pulled it in front of the e, but then after that, I know you could like divide it. I don't know. I just had a hard time with the structure of it.
Okay, so that's interesting. What about the second one? Problem 2, which technically is the fourth thing. 0. Someone type 0. 0 for which one? 1c or for 2? So you thought this was 0?
Yeah.
Well, how would you know it's 0 if you don't even know what x is? I mean, to get a numerical answer like 0 or 5 or 17, like how would you know it's like an x? The only way you can do that is if you believe this simplifies to 1, like everyone cancels out, which it doesn't really. I mean, log of 1 equals 0. So I don't know if you believe that this all simplifies to 1 that's under the radical here. That's how you can get a constant. But in general, when there are a bunch of x's there, you'd have to know what the x's are in order to get a number. Someone sent me a private chat for 1c. They think the answer is x squared over y to the 5th. We'll see. Looks like we don't know what that is. Guesses down here. Group 2. Did you guys meet with your groups and actually try these together? I mean, did you guys meet with your groups? Serious question. No? Okay, we'll see you guys, right? Hold on. I did give you. I did. You remember this? You guys need to work on it. I know it's hard, but really, you are in a safe space. Really don't be shy. Really speak your mind. There are times when you need to speak your mind. And honestly, I'm also happy if you can just say, you know what, I didn't know what to try. Or, you know, I looked at this and I thought about doing this, but I this part confused me. Or like literally just getting to you to talk is actually pretty important in and of itself. Like I'd really like you guys to not be shy, to feel like, oh, I don't want to say anything stupid, or like that's not going to happen, right? As I mentioned, I don't expect you guys to know everything, but I do need to know where you guys are in terms of your thinking in order for me to better help you and to make sure that, you know, because right now it's very low stakes. Like whether you get the answer right or wrong, it's not going to affect you at all. But when the test comes around or the project comes around and you're actually getting graded on stuff, at that point you want to actually know what's going on. But it's going to be hard for me to prepare you for that if I don't know what you know versus what you don't know. You know, like as a teacher, if I just be like, well, I spoke about this in class, I guess they know it, and I put it on a test. You know, it doesn't help you out if you don't actually tell me that I don't know it. So, yeah, speak up. And I mean, it's not even, I didn't even put you guys into your real groups to say. It was just something I did in the moment just to get you guys some support in these lonely times. So whether or not you met with your group is also not going to be hurt you. So you could just say, no, I didn't meet with the group. So did you guys meet with the group? Did group 1, did you guys meet up?
No.
No. Group 2?
No.
Group 3?
No.
Okay. Now we're all on the same page. All right. Okay. So let's actually go through this. Now, we have a lot to get through, so I'm not even going to talk about you guys not meeting up, but that's something for another time. So let's actually just go through. Well, some of you did try some of the problems, so at least that's I'm thankful for that. So let's actually get through these, make sure that we all kind of know what to do, how to get the answers, some important things to think about, some important concepts and ideas, as well as there are things that you learn from taking your classes that don't have to do directly with the material. And I also want you guys to take that seriously. So how you relate to your peers, you know, like how, if you're in a company or something, like how you get along with your team, how you get along with your manager or boss or your superiors. These things are all important. These things are things you want to be able to cultivate. And you should take that seriously. So, you know, I put you guys in groups. You should take it seriously. Like, you know what, let me check in with my group. Let's go into a WhatsApp group. Let me send them a chat like, hey, what's up? Just to check in, whatever, you know, just to kind of get that camaraderie going. These skills are actually very important, especially to you guys. You guys are in business. Business is all about relationships, right? Building a business is about knowledge and knowing the mathematics and knowing the business rules and knowing the laws and knowing all that stuff. But, you know, business, ultimately, you want to benefit people, and that's how you get it to really grow and take off and become successful. So you need to really learn how to talk to people. Very, very important. So don't be shy. Just use this opportunity. It's a low stakes environment to actually cultivate that. So that being said, let's actually move on. So let's start here. Problem 1. As you're going to realize with a lot of these problems, there are more than one ways to do it, more than one ways to skin a cat. I will sometimes do each problem in several ways just for you to see that I could have done it in multiple ways, and whichever one of these ways that you notice would have been fine. If you tried it a different way other than what I showed, and you're not absolutely sure that that was legit, or you just got the answer by accident, you can let me know what you did, and I can tell you if that would work in general. But other than that, let's actually just go through these and see how they're going to work. Okay, so part A, we have e to the minus ln2. Now, tons of ways I can approach this to simplify it. Here's one way. Let's say I first decided, oh, I want to use the law of exponents. I could actually write this as, I could factor off the minus 1, right? Because that's a rule. Since, you know, if I have x to the ab, I can always write that as x to the a times x to the a all raised to the b. So it's like my b is minus 1 and my a is ln2. I could do that. That's I'm following the rules here. There's another rule that says logs and exponentials cancel each other when they have the same base. So that's just going to be a 2 in there. So I have a 2 to the minus 1. And so this is because I know if you have a base and you have a log to the same base, they can kind of cancel each other and you just get that thing. Right? And remember, ln means base e. So you have log to the base e in the power and you have e as the base. They can kind of cancel each other. And so here, 2 to the minus 1 is, of course, a half, because we know that that rule that x to the minus a is just 1 over x to the a. So a half is the answer, which I believe was the guess, a half. So that is correct. There are other ways you could have done it as well, though. E to the minus ln2. I could have done something like, well, I know like the rule here tells me that negative powers mean 1 over, so I could have just done like 1 over ln2. And then again, I could use the rule that cancels those guys. And again, I get a half. That could work. Or I might have seen a log rule to start out. We know that for logs, if I have a constant in front of the log, multiplying the log, I can take that constant and move it up as a power of the thing being logged. So this is the same as ln of 2. I can take that -1 power and move it up. So that's a rule. Then I could cancel this. So then I end up with 2 to the -1, which again is a half. So you can get a half tons of ways, as long as you're following a rule and you are following it exactly. I do want to mention that there is a common mistake that can occur here, which is not something that I just want you to know as a mistake in this context, but I want you to take this as a general admonition and warning for the kind of things you want to look out for, kind of mistakes you want to avoid. And it's something like this. So someone might see an e to the minus ln of 2, and they'll kind of remember that rule. Wasn't there a rule that says something like the logs and exponential will cancel out, so e's and ln's always cancel out? And so they'll be like, oh, well, I can cancel these right here. And so what I'd be left over with is a -2. And they go, oh, it's -2. But that is actually incorrect. And because we know the answer is a half. I got a half a tons of different ways. I mean, once you can find the answer like 5 different ways, like chances are you're doing the right thing, which is another reason why groups are great. Because if you have like 5 different group members, you all came to the same conclusion, even though you all went about it with different assumptions, then chances are it was a great idea. And so you can kind of give yourself a sanity check. Because as human beings, it's very easy for us to get kind of boxed into one way of thinking. And then sometimes that thinking is not correct. And we don't recognize it because we have no one else to bounce ideas off of. We kind of do everything on the lonesome. Not great. So that's actually not correct, right? So not right. Now, why it's not right is actually very important for you to recognize that that would have been the wrong thing. Why is that the wrong thing? Well, here's the rule that you are trying to apply. So I gave you the rule a log to the base a of x equals x, right? So you can cancel these guys when they're right beside each other. Notice that this does translate, which means e to the ln of x is just x, right? So your e's and ln's should be able to cancel. Now, what I want you to notice is that there's nothing in front of the log, right? And that is actually very important that there's nothing in front of the log. Notice that this part right here, there's nothing here. However, if you look at the problem, you'll notice that there is something there, right? So when it comes to mathematics, this is basically the idea. And it's why I told you to memorize certain formulas, know them exactly, is because in some ways your formulas are like templates. You should be able to take a rule that I've given you and literally drop it right on top of the problem you're looking at, and everything needs to fit into a certain slot. Anything that's out of place, it means you can't apply the rule. You just can't do it. Right? So that's actually very important. So this is one of the things I want you to get away from this is the need, especially when it comes to mathematics and laws and taxes and all that stuff. There is a need to be pedantic, to really read the fine print, to really notice the little quirks and things out there, because otherwise you'll get into a lot of trouble if you're not paying attention. So you want to know that when you're applying a rule, it applies to your situation exactly. There's nothing out of place, nothing out of order. It's that way in math, and it's that way for a lot of things in life. There are sometimes you can use a rule, there's sometimes you can't, right? And that is actually very important as a general idea and rule and concept. What you will notice from what I was doing above here is that in order to kind of get that e and ln to cancel, you would notice that I had to do something first. I looked at this and I noticed, hey, there's a minus sign in front of this ln. What I need to do is I need to move it out of the way. So I use the law of exponent to accomplish that in this situation. Again, here, there's a minus sign. I need to move it out of the way. I use the law of exponents to get that to happen. Oh, here, there's a minus sign. I need to move it out of the way. I use the law of logarithm to get that to happen. So the point is, the rule I wanted to apply did not apply right away. So I needed to use some other rule to put it into a situation where I could use the rule that I want to use. And so sometimes you can know that you can stack rules on top of each other, right? Which is what, as a business, you would do all the time, right? So there are certain things that when it comes to taxes, the average person can't do, but a business can do. So you'll know that there are certain things that you would do, you would make sure you would do them through your business as opposed to through yourself as a person, right? So you would make certain charges on a business credit card as opposed to your personal credit card, because there are certain rules that would apply when you use a business credit card that don't apply when you use a regular credit card, like things of that sort. So there's a middleman that you'd have to put in there. Between me and this service, I need to put my business credit card, because as it stands now, I'm not allowed to apply certain rules and I'm not allowed to take advantage of certain rules. So mathematically and as a general concept, this is very important for you to know. So I do want you to not just think, which is the trap that a lot of people fall into. They just think of the rules as math, as the rule of math, but it actually applies way more generally to technical rules than you would think. Being good at math helps you to be good at navigating rules in general, especially ones that are complicated, like rules of taxes and business and laws. So it's very important that you know that when you're in a certain situation, you want to apply a rule, your situation has to fit the rule exactly. If it doesn't fit the rule, you have to see, is there some other rule that allows me to circumvent being able to apply this rule? And that's very important. So that's a very common mistake in mathematics and in life if you want to get really general about it. So it's very important. So like I said, you won't have to do a lot of these things directly, but hopefully you actually struggled through these problems, because the lessons you pick up along the way will be very useful in the future if you're doing things correctly. If you just kind of go through this math class and then forget about it at the end and never really learn anything, that's on you, right? All these people, all these adults you hear, no, college was useless, man. I just did it to get a degree to get a job. Well, they didn't do college correctly, actually. If you went through 4 years of college, spent 4 years of your life, and you learned nothing, that's your fault, okay? Let's continue. So here's another one. And again, tons of ways that we can approach this. I have e to the ln of e cubed. I know that e's and ln's cancel when they're right beside each other, so that can go away. And then I have e to the ln of 3, and then I know that I can cancel those. So the answer is 3, which I believe was the guess earlier. Could have done this another way. I could have said, okay, I have e to the ln of e to the 3. You know, I could have canceled this one first, and then I would have ln of e to the 3, and then can cancel that one because it applies, a rule applies, and I get 3 again. Or having e to the ln of e to the 3, I could say, let's say I cancel this one again first. So I get ln of e to the 3, but I could do something like move this 3 down in front, and I get ln of e. We should recognize ln of e as 1, which gives me, again, 3 as the answer. And so why is this 1? Well, again, because you should know that log to the base a of a is 1, since when the base of the log and the number that you're plugging into the log are the same, you always get 1 as the answer, because we have that rule that says log to the base a of a to the x equals x. And if you would notice here, your x is just 1, right? A is a to the 1. That was a rule that we had, okay? So again, know this as a rule. More than one ways to skin a cat as long as you're following the right path. More generally, conceptually, as a life lesson, you should know that there's often more than one path to a goal. So you're trying to get a business idea off the ground and someone says, nope, you can't do that. Chances are you could do something else and get there. Do whatever you see first, do what you're comfortable with. None of these ways are inherently better than the other. Whatever you see, whatever you can apply, get it done. And get to the answer, which is 3 in this case. Now, we had a guess for this one last minute, but agreed it is one of the more complicated problems. But again, tons of ways you could do this one. Let's say here, I have e to the ln of x squared minus 5 ln of y. I know an exponential rule that says subtraction in the power really means we're dividing things of the same base. So one way I could do this is to e to the ln of x squared over e to the minus 5 ln of y. I would realize that I can cancel that to get an x squared, but I would know that I'm not allowed to cancel these, right? Because the minus 5 is in the way. What do I do? Tons of things I could do, but let's say I decided to move the minus 5 up using another log rule. Now I can cancel. That shouldn't be a minus 5. Because when you move things in the bottom, it takes the positive power. So now that would cancel. And I get x squared over y to the 5th, which I believe was the guess last minute. Or I could have done e to the ln of x squared minus 5 ln of y. I could remember, oh, there's a rules that when I have subtractions of logs, I can combine them into one thing. However, it doesn't work if there's something in front of the log, so that 5 is still in the way. So what I could do here is actually just take this as e to the x squared minus ln of y to the 5th. Move that guy up first. That allows me to combine the logs into a division. Then I'm allowed to cancel those guys. And again, I get x squared over y to the 5th. So that's the answer. Or I could have done something else. E to the ln of x squared minus 5 ln of y. I could have thought of this as that rule where we can multiply things of the same base means adding the powers. And again, this guy would cancel to give me an x squared. This guy I know I cannot cancel. So instead what I would do is I would rewrite this as y to the minus 5. Now I can cancel. And so then I get x squared times y to the minus 5, which of course y to the minus 5 is 1 over y to the 5. So that's again x squared over y to the 5th. Many ways to get to the same thing. So yeah. As long as you're applying the correct rules in the correct way, there are often going to be many ways to one goal. There isn't just one way to get somewhere. Very important that you know that. Be flexible in your thinking. Sure, take advantage of what you see first and what is the easiest to accomplish. But in general, you should know if one thing isn't doable for you, you can do other things as long as you follow the right rules so you don't get in trouble. Here, expand and simplify. Expanding things like this, they are useful for more sophisticated operations. So for example, if I want to do calculus, want to take limits or derivatives or integrals of something, then expanding a logarithm, for example, would be very important. There are times when we want to contract things and put them together, and that usually comes in when we want to do things of lower level operations like algebra and pre-calculus. We would tend to take things that are spread out and move them in. So like if I have a quadratic equation, I'd want to factor it and pull it in order to solve that equation. So that's a general concept that comes along with mathematics that you can know about. But there are times when having something in a compacted form, it's better for you to spread it out. So that's what this wanted to test your skills on. Plus, I just wanted you to get used to manipulating the rules and learning the rules. So one thing I could do here is rewrite the radical as a power. Why would I do that? Because all the rules I have memorized have powers in them, not radicals. And because I want my rules like a template, I'd want to write them in a convenient way. There was no rule that I gave you that had a square root in it. So it means it's not a template. So I'd rewrite it. Then there's a rule that says I can bring this half down. And then there's a rule that says log of a division is actually a subtraction of logs. So I can subtract this guy. Notice that I put parentheses around these guys. Is that okay? Is that good? Everyone following? It's not good. Something's wrong. What's wrong?
Wait, I'm confused where you got the 1/2 power, or was that in the original equation?
It's from
Okay,
the radical.
no.
Yeah.
Oh, right. Okay, I see. That makes sense. Thank you.
But what's wrong with what I've written here?
Does the 1/2 apply to all of it?
It applies to all of it because don't forget your parentheses. Which means if you're not writing parentheses, you'd have to write a 1/2 here. So I could expand that parentheses and put 1/2 on both, but I'll just leave it out there for now. So to keep going, here I have a product, and we know that log of a product is a sum of logarithms, so I can actually break that up into a sum. And I would have that, right? Agreed?
Where did you get the minus L and X from?
For this part, remember there was a minus that was here, right? But for this part, remember that ln of something times something equals ln of that thing plus ln of that thing, right? So it's like here, maybe I should write it as A so you don't, A and B so you don't get confused. AB means AB. So it's like in this situation, my X was the A and my X plus 3 squared was the B.
Yeah, I see. Thank you.
So are we good now? So we're not good. What's wrong?
I think we're good.
You think we're good? Yeah, we're not though. Like I'm telling you, we're not. So what's wrong?
Is the ln distributed supposed to be negative before the x plus 3?
Right. Again, it's the same mistake that we did earlier. Not putting parentheses. Right? Whenever you're subtracting something that's expanding, the negative sign has to be distributed. You remember to do that by putting parentheses. So this is actually 1/2 ln of x squared minus 1 minus ln minus ln. So yes, the rule says plus, but when you're expanding this one, you get a minus minus. That's because there was a minus in front of it. So the negative has to be distributed when you expand it. So things like that, you have to remember how to use parentheses properly, your algebra. And these are the kind of mistakes where I know some of you, well, let's say it. Let's give you guys the benefit of the doubt. Probably some of you are thinking, why do we have to do this by hand? Like, I mean, in real life, we use computers and I can use my calculator. So these are the kind of mistakes where even if you're using a calculator, you would get things wrong because you're entering them wrong. Not knowing to use parentheses when you're entering the input, your computer is only going to be as good and as accurate as you are inputting it. So if you're in a situation where you're entering data and you're just not entering it according to the right rules, you're going to get the wrong output. So it's just like PEMDAS and all those things, these algebra rules, they're important even in the event that you're using technology. So it's very important that you actually pay attention to these rules and you don't do anything too crazy. And I think that was a cubed, and I randomly changed it to a square and no one warned me. So we have that, yeah. Of course, I want to expand and simplify. So having a cube is kind of not as simplified as it could be. I'd probably move that down. To get that. So far, this is fine. I can expand the 1/2, but I'm going to wait to do that. But this can actually get simpler. Does anyone see how I could make this even simpler? It's actually possible to spread things out more, if you guys see it.
Can you make 2 x's since it's x squared at the beginning? Like pull the x out? Oh wait, no, never mind. I was gonna say distribute it, but the 1 there's on next.
Yeah, there's a -1 there. But yeah, you're kind of seeing that there's a square here, so that kind of maybe we can do something, but factoring it out is not the thing. Anything else you can think of? I mean, the entire expression as a whole, the x squared -1 should actually kind of jump out at you and remind you of something. Probably something you used a long time ago, but.
Could you do like ln x -1 and ln x +1? Separate.
Yeah, that's factorable, right? So that's a difference of squares. So I can actually factor that into x -1 and x +1. And so I can apply that rule where I can now distribute the ln across the product. -1. So ultimately this becomes a 1/2 x -1 plus a 1/2 ln of x +1 minus a 1/2 ln of x minus 3/2 ln of x +3. And that's like expanded and simplified as much as possible. If this were a calculus class and I was asking you something like differentiate this, then what you would have done or should have done is to get to here first, which with a lot of practice, like the typical calculus student would be able to get to this line a lot quicker than we did. I was going through it very slowly. but you would first get to here before you try to apply something as sophisticated as differentiation or integration or something like that. Now, again, just to be transparent, you guys, for what the math we're going to do, you guys won't really, I can't think of a situation right now where you're going to actually need to know how to do this. But again, it's less about the subject matter and more about you cultivating the behavior of knowing how to manipulate rules, knowing how to apply things in certain situations based on the situation you find yourself in, how to think yourself out of a box, how to know that these facts that I know, I can manipulate them to deal with this random mess of a situation. And just practicing that in and of itself as a skill and learning how to look at certain facts that you know and look at a convoluted problem and actually disseminate that problem into something that's more manageable to you. That in and of itself as a skill is very important. And it's one of the skills that mathematics builds. So when people are like, you know, I never used quadratic formula in my life. Well, hopefully you've used the fact that you take a big problem and break it down into smaller problems to help solve it better. If not, your life is probably a mess. Because that's an idea that would apply all over the place. Sometimes big problems are just a combination of a little bunch of smaller problems. Right? Another life lesson there we can learn from this class and from mathematics. Let's keep going. Sometimes combining is what you want to do. So sometimes something is spread out and you actually want to pull them together. Like I said, that is something that tends to go with more basic operations like solving an equation, solve for x. You'd want to tend to pull things together instead of spreading things out. So this is going to test that skill. So again, several ways I could do this. I'll show you guys two or whatever. So one thing I could have done was I can take that power 3, move it down. And so now what you're going to realize is I have a bunch of common terms, log to the base 2, log to the base 2, log to the base 2. So now it's like I have 1 apple minus 3 apples plus 4 apples. That means I have 2 apples. Right? So that guy simplifies into that one tiny expression, which is super cool, super useful. Or someone might have seen the opposite one, where instead of moving the power down, you would move the power on the last one up. Right, so move that guy up. So instead of taking the 3 and moving it down, instead we're going to take the 4 that was in front and move it up. That's allowed, it's a rule. So what can we do now? Well, now I have a bunch of logarithms that are being subtracted and added. I know when a log of a subtraction, that just means division. A log of the division. And I know an addition of logs is really logs of the multiplication. So of course, this cancels into that. And we have log to the base 2 of x squared, which again, I can use a rule and move that down in front. All right, I can take this guy and move it down. That's a rule. So I get that. Right. Same thing, just depends on what you saw first. Let's keep going. So we're going to get through these. That would take us through chapter 2, which is not directly applicable, but indirectly applicable. Like I said, eventually you're going to be doing all sorts of word problems where you have to translate to math and then be able to solve the math. And you need to know how to do it by hand, because even when you're entering things into a calculator, you need to know when you should put a parentheses versus not and things of that sort. So it's giving us a good, especially some of you might not have had math for a while, or at the very least, you know, the winter break, you probably forgot a lot of the math that you knew. So it's nice to just start the semester getting back into the groove of doing mathematics. So that's what we're doing. But we start, you can say, your official curriculum tomorrow, which is chapter 3, and that's when your homework starts as well. But let's just actually get through these guys. A couple ways you could do this one. So you have e to the x equals 12. We know that logs cancel exponential, so what we can do is just use log of the same base and throw it on. I call this, you know, log both sides. So if I say log both sides, that's this is the operation I'm talking about. Now, what happens is that this guy would cancel, and you'd immediately just get x equals ln of 12, which is just, you know, it's a number. It's the power that you have to raise e to in order to get 12. Yeah, that's it. Log both sides. There were other options. Just knowing a rule could actually get you to the answer right away. We know that a raised to the c equals b is the same as saying log to the base a of b equals c. And so what this means, if I have e raised to the x equals 12, this is the same as saying, you know, log to the base e of 12 equals x, just by applying this rule, where my a takes on the role of e, my b takes on the role of 12, and my c takes on the role of x. And of course, log to the base e is just ln. So you could see that as the answer right away as well, just by knowing the rule, which is law 1 of logarithms. So it's a rule you should know. This is an important kind of equation for us to solve. Like, this is more than just, you know, a life lesson. Like, you specifically need to know how to solve an equation like that specifically. You'll also specifically need to know how to solve an equation like this. So like I said last time, a and b are very relevant. Here, what you can do is, again, knowing that exponentials cancel logarithms, you can throw an e in here. I'd refer to this as e both sides. But I do want to make a note that this is wrong in terms of language. So it's not a great phrase, but it's how myself and other people might refer to this. So sometimes you can say raise both sides to the 2 or raise both sides to the e. They really mean put e as the base and put the things in the power, right? Again, the e and the ln would cancel, and you would just get x equals e to the 9 in one step. Again, or you can know, because log to the base a of b equals c is the same as saying a raised to the c equals b. That means if you have ln of something equals something, this means you have log to the base e of something equals something, which means you can take the base, put the guy that's on the other side as the power, and then your x would show up here. So again, you can get the answer like that just by knowing the rule. Here's another one. ln both sides. So that is going to leave you with 5 minus 3x equals ln of 4. Now, ln of 4 is just a number, so I'm just going to pretend it's a number. I can move it to the other side, minus ln 4, move the 3x to that side, and then divide both sides by 3. And we've solved for x. So we're going very quickly through this. That was the plan, because I assumed you guys would look at it over the weekend and you would already have spent a lot of time thinking about it. So I could rush today and finish everything. So here, but of course, if you have questions, just stop me. Here, remember I mentioned when it comes to solving equations, combining stuff is what you'd want to do. So for example, if I have logs all spread out all over the place, I'd want to combine them into one big log. So I tend to move them to one side. I can use that rule that tells me I would combine the logs that way. Then we're in a previous situation, e both sides. Then I would have x times 2x plus 1 equals e squared. How do we solve this equation? Quickly, some ideas.
Do you distribute the x?
Distribute the x. Now what? What kind of equation is this? Let me ask that. If you had to put this equation in a category, what would it be?
Exponential.
No. Remember what exponential means? The base is a constant, the power is the variable. You have the opposite here. You have an x is the base and a constant is the power. It's not an exponent. Huh?
Linear.
Not linear because of the square. Linear means it looks like a square. It's quadratic. So what do you do when you have a quadratic?
Use the quadratic formula.
You can, but you do something first, right? You'd have to move everyone to one side and get 0 on that side. So now what you would try to do is you would try to factor. But that's when you have whole numbers, they're very nice. You want to think of two numbers, you multiply, you get the constant, you add them, you get the middle term. And if there's a number in front of here, you have to try the AC method or something else. But it doesn't work here because e squared is a very weird number. So that leads you to the second thing, which is where you apply the quadratic formula. And of course, hopefully you should remember that when ax squared plus bx plus c equals 0, it means that you can take, of course, your a is not equals 0. It means that your x is going to be minus b plus or minus the square root of b squared minus 4ac all over 2a. Applying that here, you'd realize your a is 2, your b is 1, your c is negative e squared. So applying the quadratic formula, we would get x is minus b plus or minus the square root of b squared minus 4ac all over 2a. Something we'd have to notice here, this actually breaks down into two parts. So I have x can be minus 1 plus the radical, 1 plus 8e squared over 4. Or I can have x equals minus the radical. What I want you to recognize about this one is it's negative, which is bad, because in the original, I had ln of x. And we saw last time, logs are undefined when you take a negative. So ln of x would be undefined. So you would reject this answer. It turns out that this one actually checks out. I'm not going to show you, but take my word for it at this point. So we're already a little bit over time. I don't want to take longer than I have to. So that's that one. Here again, want to solve an equation. I have a bunch of logs spread out. What I would do is combine them, right? So this is log of x times x minus 3 How do I solve for x? What's the next move? Ideas, guesses? Shout out, first thing that comes to your mind.
Distribute the x.
Yeah, distribute the x.
Okay, then what?
Can we distribute the log?
No.
Or bring the 1 over and then do the quadratic formula again.
Remember, I should mention that because it's a common mistake. Log of a plus b does not mean log of a plus log of b. Remember, it has to be a multiplication for that to happen. Right? So remember the rules, very important. Logs do not distribute across sums. A lot of things don't. Multiplication distribute across sums, limits distribute across sums, derivatives, integrals distribute across sums. Logs don't, powers don't, radicals don't. Okay, so there are a bunch of things that don't. You have to remember those. Logs is one such thing. There is no such rule as in red, so we cannot distribute the log. You thought of moving it to one side and use quadratic formula, but it's not a quadratic because there's a log there. And I mean, we've been in this situation before, I think like the third time today. When you have log equals to a number, right? And here we had log x equals to a number. Here we have log of something equals to a number. What is the strategy?
Got to cancel the log out.
Yeah, how? What cancels the log? So
Putting
remember
the
to,
same
what?
base. When you
Same
put the
base. What is the base of this log?
1,
No. When it's not written, what is it?
Is it 10?
It's 10. So what you do is 10 both sides, cancels on this side. That side becomes 10 to the 1. That you recognize as a quadratic. Here we have whole numbers, so I try to factor. It has to be a plus and a minus to get a negative. So something like a -5 and a +2 should work. So I know that my x equals 5 or x equals -2. Of course, for this one, I'd reject since my log x and log to the x -3 undefined for this, right, which was in the original. So the 5, however, does check out. So we can check this. Notice that if I plug this into the left-hand side, which is, log x plus log of x -3, here I would get log 5 plus log of 5 -3. That would be log 5 plus log 2. I can combine that. That's log 5 times 2. This is log of 10, which we know is 1. If I look here, there is a 1. So that actually works out. This is equal to the right-hand side. So this checks. And x equals 5 is the only answer. Last one for the road. Like I said, tomorrow we'll start chapter 3. which is the financial math portion of the class, which we're going to start with interest. So if you want to read ahead on simple interest, compound interest, compound and continuously interest, you should do that. Here, same idea, use logs to cancel exponentials. Here, I would use log to the base 2. That just gives me an x squared plus 1 equals log to the base 2 of 5. Remember, this is just a number, so don't let it confuse you just because it looks weird. It's just a number. You can plug it into a calculator to get a decimal. So what I would do is move the 1 to that side. And then I can just take the square root. Of course, I'd get a plus or minus. I can notice that this is okay since x is squared in original. So whether it's positive or negative is not going to bother me because I'm going to square it and make it positive anyway. So non-issue there. But you might be concerned with, is this okay? And why? Because if what's under the radical is negative, it's a problem, right? You can't actually square root the negative. But you can know that it's not, and that's because, but note, if you take log to base 2 of 5, that is actually going to be larger than log to the base 2 of 4, which is 2, right? So this means that log to the base 2 of 5, if I subtract 1, that's going to be larger than 2 minus 1, which is 1. So it is positive. And so that's the actual answer. We are good. Okay. That's it for today. Tomorrow we start chapter 3. Thank you for your attention. I know we went over time, but hopefully you guys will participate a little more quickly next time. For now, I'll let you guys go. Have a good rest of your day, and I will see you guys in the next one. Ciao.